Welcome students. So from this application of derivative, we're solving this maximum and minimum problem. So for solving maximum and minimum problem, we are just taking a normal curve that is ups and downs, and we'll call this is maximum point, this is minimum, this is maximum, this is again minimum. Now, and at that point, f dash x is 0. Now, in the curve where f dash x is 0, for all x is equal to c, can we find the maximum or minimum value? Maybe we can find the maximum or minimum value, maybe not. So in these cases, we can define these 3 points, that is stationary points, critical points, and point of inflection. So let's us define this stationary point first. So what is stationary points? Look here, I'm taking this two curve, that is y is equal to sine x, and this curve I'm taking y is equal to x cube. Now for this function sine x, in this point we can find the maxima, this point minima, this point minima, this point maxima, and at this point f dash x is 0. So for this curve, for every f dash x is 0, we can find the maximum minimum value by the graph only. I'm saying just by the graph, take any normal graph, continuous graph, and then check this f dash x is 0 or not. And if we find the maximum and minimum value, then we call it turning point. Now, look, in this case, at that point x equals to 0, we can find f dash x is also 0. Because y is x cube, so what is y dash? Y dash is 3x square. So for x is equal to 0, f dash x is 0. But look, this is not a maxima or minima. That x is equal to 0 is not extremum. That is, it is neither maxima or minima. So in these cases, we will call this as stationary points. Maybe f dash x is 0, it will imply these 3 cases. That is maxima, minima, and that's not extremum. So in these 3 cases, for this we will call this point is stationary point. So what is stationary point? Here is the definition. A stationary point of differentiable function of one variable is a point on a graph of the function where the function's derivative is 0. Definitely f dash x is 0, but where it is stop increasing and decreasing. At that point, the function is not increasing or not decreasing, but the maxima or minima can exist, or maybe no extremum also is a possibility. So all these type of points are called stationary points. So next, check critical points. Here I'm taking this two curve, very common curve, that is x is equal to mod x and y is equal to mod x and y is equal to mod x minus 3. So we all know that at x equals to 0, f dash x at x equals to 0 undefined. When we are studying differentiability, the definition of the differentiability, that time we solve this type of problems. Its mod function is given, so this is undefined. This derivative is undefined at x equals to 0. And for this function, it is undefined, that is f dash x at x equals to 3. Undefined. But check, in this point, the function has the minimum value, since f of 0 is 0. And in this point also, this function y1 have the minimum value. So this one is y at x equals to 3, it is 0. So for x equals to 0, this function has minimum value, and for this function for x equals to 3 has minimum value. But this first derivative does not exist, and definitely it is not equal to 0. It is undefined, so it is, and it is not equal to 0. So if it is not defined, we can't check its sign. So if it is not defined, so we can't say it is equal to 0 or non-zero. So in this type of problem where the first derivative is either 0 or non-zero, but at that point the maximum and minimum value exist, so this type of points are called critical points. So here is the definition. A critical point is a point in the domain of the function where the function is either non-differentiable or derivative is equal to 0. So in this both the cases we call this is undefined, non-zero, not non-zero, this is undefined. Now, so in both the cases, we call this point is critical point. So every stationary point, we can say it's a critical point, because in every stationary point, this f dash x is 0. Now check the point of inflection. Here I'm taking this two curve. This red one is defining by y is equal to x cube plus x, and this green one is defining by y is equal to x cube. Now check is this point x equals to 0. The point in this point, find f dash x for y1. It is 3x square. So f dash x, that is y1 dash at x equals to 0, it is 0. So f dash x is 0. First derivative is 0 at equal to 0, x equals to 0, but it is neither, it is not maxima or minima. And if we check this function, find y dash is 3x square plus x plus 1. 3x square plus 1. Now put x equals to 0 here. So you will find this is a non-zero quantity. Okay. But one thing you can notice for this two graph, this is changing. That is, the concavity of the graph is changing. Here it is like this and this. That is from convex to concave or concave to convex. That is, in simply we can say a sad face changing into a smiley face, or a smiley face changing into a sad face. In this both the cases, this point is called point of inflection. Maybe the first derivative is 0 or non-zero, but the second derivative have to be 0 at that point. So this is the main criteria for finding the point is inflection or not. Second derivative should be 0 at that point. You can check for this function also and for this function also. In both the cases, second derivative is 0. But before this point, the function is not changing its nature. That is, it is not changing from negative to positive, or it is not changing to positive to negative. So nature is not changing, but the second derivative is 0 at that point, and the concavity of the graph is changing. That is from the smiley face to sad face, or the sad face to smiley face. So this type of points is called point of inflection. So here is the definition. Point of inflection is a point on a continuous plane curve at which the curve changes from being concave to convex or convex to concave. So this is the definition of point of inflection. So let's study these points in a single graph. So that will be more clear. So here I'm taking this curve is equal to y is x minus 2 whole to the power 4 and x plus 1 whole cube. So by the graph, I can say that this point, take another, this point, and this point, f dash x is 0. So now check what is f dash x. Y dash is given by 4 x minus 2 the whole cube into x plus 1 the whole cube plus 3 into x minus 2 whole to the power 4 x plus 1 whole square. Now simplify it, you will find x minus 2 the whole cube into x plus 1 the whole square into 7x minus 2. So if y dash is 0, that means it will imply these 3 points, x is equal to either 2, x is equal to minus 1 or x is equal to 2 upon 7. Okay, so check this point x is equal to 2. If you find the second derivative, and you can check also, here I'm checking by graph only. At this point the function is minimum 2 by 7. This point is here. In this point we can find the maximum, local maxima and local minima, but at x equals to minus 1, neither maxima nor minima. In fact, the sign of the first derivative is not changing before minus 1 or after minus 1, but its concavity is changing. So x is equal to 1 is called point of inflection. So it is the point of inflection, and these points are called stationary points, or you can say these points are called critical points since f dash x is 0 at that point. Now you can check the graph for this function also, that is x minus 2 the whole cube, x plus 1 the whole square and 7x minus 2. But this function, the function will like that. Whenever you are finding a differentiation of a particular function y is equal to f of x, you find f dash x. Now f dash x is also representing a function and it has a particular graph. So you can also check the graph. Here is the maxima, minima. This point is also minima, but look here, this is point of inflection. That means this is changing from this to this. So take any function and check these points so that your concept will be more clear. So next, check some maxima minima for a function. That is some problems. So first problem is here. Find the positive numbers x and y such that x plus y is 60. So now if x plus y is 60, and we need to find the maximum value for this function x into y cube. First of all, we need to find this f of x. So let's find first f of x. So if x plus y is 60, then y is given by 60 minus x. And then put the value of y into this function, that is x into 60 minus x the whole cube. You can change this function into function of y also, and you can find the derivative, or you can check the maximum minimum. Both the cases the problem is correct. So fx is given by this. Now our first work is find f dash x and f double dash x, and then find the point where this f dash x is 0, and then check f double dash c is, for maximum we need to find this is less than 0 or not. So this is our first work, second work, third work and fourth work. So let's check the first work. differentiating this function with respect to x. So we have to apply the chain rule, the u into v form, and chain rule also here for 6t minus x the whole cube. So if we differentiate this function, you will find the 6t minus x the whole square and 6t minus 4x. This is the first derivative. Now let's find the second derivative. Again apply this u into v form, that is formula for product if double dash x. So differentiate this function. I think it is very easy to differentiate the function. I don't need to explain it. So if we simplify it, you will find this function is given by minus 12 into 60 minus x into 30 minus x. So if double dash x, we need to check now it is less than 0 or greater than 0. So from this function, you can easily say this f dash x is 0 at which point x is equal to 60 and x is equal to 15. So first find the critical point. Here it is 60 and 15. For that we need to check if double dash 60 also, if double dash 15 also. Now check if double dash 60. So you will find this value is 0. That means in this point, no extrema exists. That means it is neither maximum or minimum. Now check this 15. If double dash 15 is minus 12 into 60 minus 15 positive, 30 minus 15 positive, and minus 12, that is ultimately negative. If it is negative, then at x equals to 15, the function has maximum value. And if x is equal to 15, then y is equal to 45. So here is the required numbers, that is 15 and 45. So for these two numbers, this function, that is x is equal to y cube, is maximum. So check the solution. And here is your next problem. Find the maximum value of the function x to the power 1 upon x. Look, this function is given function to the power function. Okay, so differentiating this function is a little difficult. But if we take log e both side, that is log x 1 upon x. So by the property of log, we can write 1 upon x log x. Now u into v form or u by v form is given. Now you can easily find the derivative for this function. That is log y is equal to 1 upon x into log x. So first work is to take log e both side, or you can write ln also. So differentiating this function, then our first work is find f dash x and then check the point C where f dash x is 0. So here is the differentiation. Use u by v form and find the derivative. I don't need to explain this one because all of you know this u by v form, that is how to derivative this type of function. So ultimately result is coming 1 minus log x or ln x by x square. Now for this function dy dx is if 0, that time 1 minus log x is 0. That is if 1 minus log x is 0, that means log x is 1, that means log e. And if it is given by log e, that means x is equal to e. So here check the critical point, x is equal to e. Now I'm just differentiating this equation 1. I'm not separating this dy dx and y. I'm just differentiating this function, okay, with respect to x. So what do we find? Dy dx, difference first, u into v form is given, dy dx, differentiation of dy dx is the second derivative, d dy dx2. And again differentiation of 1 upon y is given by minus 1 upon y square and dy dx. So this 2 dy dx is there, that is dy dx the whole square. And it is differentiate this one u by v form, again apply u by v form, and if we simplify it, you will find this value is minus x minus 2x into 1 minus ln x upon x to the power 4. Now, you don't need to more simplification, just put the value x is equal to e in this equation. So putting x is equal to e in this equation, we will find this value is less than 0. So if we put x is equal to e in this equation, what is dy dx? Dy dx is 0 because this is a critical point. We already checked this f dash x is 0 at that point here. Dy dx is 0, and leave this term as it is and put e here, x is equal to e here. So you will find this is minus e and minus 2 into e into 1 minus log e base e, or e to the power 4. So now if we simplify it, you will find since log e is 1, so this term will vanish. So remaining term is minus 1 upon e cube, which is less than 0. Here it is. Now if it is less than 0, then at that point x equals to it, the function has maximum value. What is the maximum value? Put y is equal to e in this equation. Sorry, x is equal to e in this equation. So e to the power 1 upon e is the maximum value. So here is the full solution. Check it. First, try to solve the function by yourself, step by step. And if you can't find the answer, that time you will check the solution. And if you can, then just find it. So find two numbers whose sum is 24 and whose product is as large as possible. So sum is given for two numbers. So take x and y, these two numbers, and the sum is given 24. And we need to find the product, that is x into y is maximum. So first of all, we have to convert this function fx into the form of x. So from here we can find the y is equal to 24 minus x and put this value here. So we will find the function fx. Now our first work is find f dash x, then check f dash c is 0. That means we need to find the value of c. What is c? And then find f double dash x and check if double dash c is maximum. The product is as large as possible. That means maximum, that we need to show this is less than 0. We need to find the point c for what? For which this if double derivative at x equals to c is less than 0. So solve it by step. First, find the value of y. So here I'm taking the function, one point is x, so another point is 24 minus x. So the function is given by f of x, that is equal to x into 24 minus x. X into y, put the value of y here, and this is the equation 24 minus x square. Then our this work, that is find the first derivative. So differentiating with respect to x, you will find differentiation is given by this 24 x, differentiate this one, you will find 24, and for x square it is 2x. Now take 2 common, so from here you can say that point is x equals to 12. For x equals to 12, the first derivative is 0. Now check this critical point. For x is equal to 12, the first derivative is 0. So our next work is to find the second derivative. So differentiating 1, just value this one is 1. So differentiating 1 with respect to x, what we will find? If double dash x is given by minus 2. Just differentiate this function 2 into 12 minus x. So you will find only minus 2. Okay. Now put if double dash c, that is x is equal to 12, this is less than 0. We have to show this is less than 0. So for x is equal to 12, the function has maximum value, and or we can say that x is equal to 12 is a point of maxima for fx. And if x is equal to 12, then what is y? So the another number is given by 24 minus 12, that is 12. So here's your next problem. Show that this x cube plus 1 upon x cube has a maximum and minimum value, but the maximum value is less than the minimum value. So our first work is find the maximum and minimum value. That is, for the function, find f dash x, then find x, this c, x is equal to c, what is the value of c such that f dash g is 0, and then find f double dash x, and then check the sign of f double dash x is greater than 0 or less than 0, and then find the maximum and minimum value. So first, here is the given function, and find f dash x, that is differentiating with respect to x. We will find f dash x. This is very simple. Differentiate this function, that is 3x squared minus 3 upon x to the power 4. Now we need to find that value c for which f dash x is 0. So put f dash x is 0 and find that value of x. So simplify it. You will find x cube minus 1 and into x cube plus 1 is 0. Okay. Now just break this factor. That is, first one is coming x cube minus 1 is 0. Now if we apply x cube, a cube minus b cube formula, the factorization form, that is x minus 1 x squared plus x plus 1 is 0. So real root only, x is equal to 1. And for the second factor also you can find, if you just apply the a cube plus b cube formula, you will find x is equal to minus 1. At that point this factor will be 0. So either x is equal to 1 or x is equal to minus 1. So these two are the critical point. We need to check first the second derivative. So find the second derivative, differentiating 1 with respect to x. Again differentiate this function. So you will find this derivative is, second derivative is given by 6x plus 12 upon x to the power 15. I don't need to explain the differentiation again and again, because you all know how to differentiate the function and how to find the value of this differentiation. So if double prime x, that is the second derivative, is given by 6x plus 12 upon x to the power 5. Now we need to check that if double dash minus 1 and if double dash 1. So let's check it. Now for if double dash 1, just put 1 here, you will find 6 plus 12, that is 18, greater than 0. That means if it is greater than 0, that x equals to 1, the function has minimum value. And put x is equal to 1 into the function, that is f of 1. f of 1 is 2. That is the minimum value. Now put x is equal to minus 1. So you will find this is minus 18, that is less than 0. Then at x equals to 1, the function has maximum value. Sorry, x is equal to minus 1, the function has maximum value. So put x is equal to minus 1 and the function f of minus 1 is given by minus 2. So look, the minimum value is 2 and the maximum value is minus 2. So what I have to show? I have to show the maximum value is less than the minimum value. So we proved it. The maximum value is less than the minimum value, since maximum value is minus 2 and the minimum value is plus 2. So here is the solution. Check this. Next, some homework, and find this critical points and point of inflection for this 4 functions. It's given here, this one, this and this. And you need to find the maxima for this function, and you need to find the positive number x and y also, and same type of problem is given here. So I think this type of problem we already solved. I think you can solve these problems. So solve this problem, and if any doubt or any problem is there, you are free to ask. Thank you.